So I'm not going to introduce myself again. This is Eolocal. That is Argentina in the world map. It's very, very far away from here. It took us a long time to get here. But we didn't earn the prize anyway. The French took longer. They are closer, but they took longer. So this is what I'm going to show. What is the strategy of Eolocal to try and sell wind turbines from the Piggott design and to make it more massive? So it's interesting to see what I just saw. Progress to date, what we have achieved so far, what we have achieved in terms of a manual, what are our next steps in the design of the wind turbine, and our next steps as Eolocal as a whole. So, what is the strategy? We have to keep Piggott's design. He's the master, so we don't want to contradict him. We want to reduce building time to make it faster. We don't want to take 6 days to build one wind turbine. That will never work for selling wind turbines. Reduce installation time. We want to install it quicker and make it as easy as it can so that somebody can install it with the manual on their own. Self or locally installed. Combine, so that's kind of an IKEA concept. Combined with 500 RPM, our other initiative. They are very complementary in many senses. You are going to see more on that on Luciana's presentation, but they are very complementary. And improve some aesthetic aspects. Some people say it's ugly. I don't agree, but... So, for the blades, we have gone to fiberglass blades, Clark white profile. The geometry is still the same. We don't want to change that, otherwise we would need arcing wind tunnel like they have in here. We don't have that. But what we have seen is that we have improved 7% on what we measured from the wooden version to this other version. So it's not a lot, but still. The idea is not how much you save in terms of technology, but how much you save in terms of time to build the blades. This is our super device to mount blades quickly, because it took us a long time to measure the distances in the blades, so now we do it very quickly. And this is easy to be done by an experienced. This is for assembling the blades, so 2 plates of metal with holes done by a machine, so we don't need to be digging holes or doing things that take a long time. So it's very easy and fast to assemble the blades. That's our super device to do the coils. We have 3 coiling things, so we do the coils in the whole phase in one set. So it's pretty quick to do a set of coils for a wind turbine. So as you can see, it's industrialized, but not so much. We're kind of in the middle of the way. We want to go a few steps further. This is the device to mount the coils quickly and not be like with a screw putting all the coils in place. This is very fast, and we do the positioning very quickly. This is a vacuum system with a vacuum pump here, and that's the mold for the casting of the stator. So that way, not only it's quicker, but the final piece is really precise, and you don't have a lot of work after you finish the casting. So that's the mold. It looks easier than it actually is. What you can see behind Quilmes is a brand of beer, so you can see why the stators sometimes don't work. This is an image of the casting itself. We had a few problems in getting the resin to fill the whole thing, so we had to change a lot of parameters, and we still don't have it optimized, but we're at it. That's the super device to put the magnets. It's pretty much the same as Piggott, but done by a machine. We made it too thin, so it broke all the time, so that's how we fixed it. Very professional. This is to unmold our magnets, because it took us a long time to bang the mold to take the thing out, and then it broke all the time, so I had to fix it, and lots of problems with that. So this is easy to unmold and very quickly. These are the rotors, pretty much the same as Piggott, only we made a few holes so that it's a bit lighter, not much, but it all sums and adds up. So it's lighter. The steel frame is really different. It's much quicker. That's where we made most of the changes, and that's what broke first. So that everything you go against Piggott, you see why Hugh would have told me not to do this. We did it and we learned it the hard way. So that's how it's working now, and we have reinforced it. This is an old version, but it's really quick to assemble, so we make the steel frame really quickly. We have positioning tops. It's only one piece, and all of the tops are in there, so we don't have to be measuring the 10 degrees and the 110 degrees and so on. So that's quicker. And that's like the final assembling. So we assemble it quite quickly, and anybody with a little bit of logic can do it pretty easily. That's the tail. A bit of improvement on the design, if you would agree. If not, I'm an engineer, so I don't know nothing about art. So that's the final thing, and there it is flying. The person who actually installed that one installed the tail all the way around, so it looks horrible, but imagine it the other way around, please. Another thing we worked on is the manual, so it's a very complete manual. Of course, I'm not going to present the whole manual here, but it's a very complete manual aiming for the self-installation of the wind turbine. Of course, it's a big challenge. It's not easy to let anybody install a wind turbine, but still we are trying with some capacity building and training people, trying to get there and have people install their own wind turbine with a manual. So that's how it looks. I'm just showing a few pictures of some pages. So we have pretty much how to install the tower, how to do the foundations, how to mount the pipes. The pipes are already sent so that they are only to be put one next to the other and not think too much. If you think, you do think wrong. That's how we explain how to put it up. Everybody does that. It's only that we put some nice pictures and step 1, 2, 3. Yeah, the truck comes with a wind turbine. Free of charge. So that's how you mount the blades, etc. There's an explanation on that. And also some pages on maintenance, what to do every year, and the maintenance and what to do every 4 years. I'm trying to run here because I'm scared of the chicken. So what to do every year, like different tasks of maintenance. And now moving on to what our next steps are, because we know that we have made several steps towards industrializing it, but there's still a lot to do. So we have hired professionals on industrial design. 2 minutes, thank you. So they are going to help us improve it and make it quicker and go closer to the 1,000 wind turbines per year, hopefully. So these are some of the problems we have. It's a complex assembly, uncomfortable work position, many independent parts, low tolerance. So things that we are going to work on. The mold is pretty sloppy, and we are going to work on that too. This is the final piece. It works very well, but it could be nicer, and I don't know, it's kind of ugly. Complex mounting, and this is the problem we had with doing things our way. A lot of corrosion, so we are basically going to put all in zinc. How do you say? Galvanize it. The diagram is not very clear, so we're going to work on that as well, the electric diagram, and work on the aesthetics. So basically see what's already out in the market and try to improve ours. And Piggott. So yeah, so that's for the next step on the design. We have many lines of work on the design, and also for Eolocal, we are working on the redesign to make it cheaper and faster. We are working on the website and the identity of Eolocal. We are going to do a smaller one because we're working on the 700 watts one. We're going to work on the 350 one and on a 2 kilowatt machine. We're starting to work with a local company that does inverters to develop a local regulator, because it's really expensive. We have to import it from the States. That's the only part that we cannot find in Argentina. And develop a commercial network first within the country, and then in Latin America, and then, who knows, Mars. All right, that's it. Thank you.